Hey, how's it going, guys? So back again, the Python BACnet X playground. So I want to do a little bit of vibe coding for a BACnet application. A little that has to do with part three of these LinkedIn articles. I've been experimenting a little bit about demand side management, some proof of concept ideas of how to lower demand charges inside buildings. And then part three will be a BACnet application. So I want to do this in the Rusty BACnet stack, um, which I have vibe coded a little bit um, on the Python BACnet stacks playground. But I want to play around with this is actually the Python API for the for Rusty BACnet. It's all Rust under the hood, but there's a really thin layer of a Python, an API for Python, which is actually really cool. So um, I have been doing a little bit of the Rust, which is really hard. I still need to do my Rust daily lessons, which I've been slacking, but I thought it'd be kind of fun to play around a little bit with the Rusty BACnet. Okay, so like, where should we go with this? What we did a while back on the Python BACnet X playground, it was BACnet server applications. So this is months ago. Hard to believe. So we did a OpenWeatherMap API tester in Python. Maybe we should just do this again. Um, so this is basically the idea that I have is kind of porting this code over to VibeApp 22, which will have this concept idea of reinforcement learning, which will slowly get into that. But for the moment, I want to just experiment with vibe coding some of this OpenWeatherMap API, and then basically recreating this Vibe app 4, but it'll be instead of backpipes, this will be let's see. So this is using backpipes. So like instead of using backpipes, we'll use Rusty BACnet. Um, okay, so where should we go with this? Like, yeah, this is the Rust version. So I do have some of the Rust version on this Python Back2Text playground as well. I'm just debating it, like how to get into this. So like I think in time, like um, kind of go through some of these LinkedIn articles and just at like a very high level of like what we're doing. So like um, so this is like a building's electrical usage um, in the scatter plot. So this down here is outside air temperature in degrees Fahrenheit. And then this is the electrical demand over here. So like this is a building full of heat pumps. So a smaller school in southern Wisconsin, full of heat pumps, which is actually a really highly efficient way to heat and cool a building is to use heat pumps. But it just happens to use electricity and a lot of electricity, especially in a heating mode. That's when they peak. So like this building peaks electrical demand at its coldest morning, which is actually over here. So it's like about 175 kW overnight in the winter, and then right at this startup peaks over 300, and then this is probably when the kids get in. um, I think it recorded 330 kW. um, and when it was, this is outside air temperature, uh 7.5 degrees below zero that day. So in Fahrenheit, degrees Fahrenheit, so that's pretty cold. um Weather extreme day. So like Most buildings, when it's 80 degrees Fahrenheit, this is like you'd peak in the air conditioning season. But these heat pump buildings actually draw much more electrical energy to heat. I think they even become much more inefficient when the heat pump has to heat, especially when so it pulls condenser water out of the ground to geothermal loop system, and then when the wells get kind of saturated, that it becomes slightly less efficient. Long story short, it peaks in the winter. And then the idea that I have for this BACnet application, I'm just going to bring over Workbench. This is the Workbench tool. I think if I just show you like in a schedule, it's like I have to pull this schedule palette in, schedule. Hopefully you guys can see this. I think I have this on the biggest font that it can do. Where's font? Just double check that. I think I checked this already. Options. It's in here somewhere. Font size. Yeah, it's already on large. So if it's kind of small, sorry. This is the only big as it can get. Looks like I can zoom in here. But a schedule. So like what a building automation schedule, which is typical to any buildings. Whoops. Let's just say the building starts up from here to here. Apply Monday through Friday. So like HVAC starts at 6 a.m. and it starts off at 6 p.m. Monday through Friday. So just a very generic calendar week. Every building automation system has some kind of a widget like this. Generic weekly calendar schedule, and then they still have like a actual calendar to program in holidays. But there's always some generic calendar feature. And then like what I want this reinforcement learning project to be is like the AI agent will be able to start the building earlier, or even run it 24/7 during cold snaps. So it'll have the ability to do this or this, or, something like that. So it has the ability to adjust schedules, but it can't go more than I think this 6 to 6 time frame is. So that is the meat and potatoes of the idea I have in mind to keep the demand from peaking. So like the demand peaks in this particular building. You just have to use your imagination that it's really cold outside overnight, and when all of these heat pumps start up right at 6 a.m., boom, that's like when the building experiences this big spike in electrical energy. But if you ran it 24/7 during that weather extreme, in theory, you wouldn't get that big spike of electricity from the startup. There would be a penalty in KWH from running equipment longer than it needs to be, but you wouldn't have to pay these demand charges. So this is basically what the AI agent is trying to do is, if we could have this idea, if we could save 30% of demand, say we trim off, the building never goes over 200 kW. That's 100 kW in demand charges, where in blog post number 2, in some of the economics on this is basically what the maintenance men do too, is like they try, we could run the HVAC 24/7, or we could try and save some energy, but you're kind of gambling because you might have you might peak the demand. You might save some of kWh, lapse electrical energy over time, but you peak that demand, and they pay. Some buildings pay a ton of money in just demand charges, and it seems to be kind of a hot topic right now. A lot of people are talking about demand side management, how to do demand side management strategies inside buildings. We'll get into this later, but this is like a math equation that AI agents are helping me come up with to try and do some reinforcement learning to see if we can not peak the demand, which is basically doing it's all it is it's doing this. So like so in some of the demand charges that I was coming up with is about $4,000 of in U.S. Demand charges would come down, but there would be somewhat of a kWh penalty too. So the demand charges would come down, but electrical energy consumption would go up. But the net costs, I think, will be still down. You'll still, the organization will still benefit from a cost perspective. So that's what we're doing here. And eventually I want to get a little bit into more of like the nuts and bolts, and these are two reinforcement learning models: deep Q network, deep Q learning, DQN, and then this PPO, proximal policy approximation. So like a really high level, Q learning is like it's a massive table, like a massive Excel spreadsheet of every possible action space that so these are all the different zone temperatures, outside air temperatures, and it's a fixed action space. So like that is Q learning, and then this continuous PPO. I still have to like wrap my head around this, but these are the two strategies that we're going to be kind of going with. And the what I want to do now is kind of prototype the BACnet application. So to do this, like what I imagine we will do here is so we're basically doing the same thing that the maintenance staff would be doing. So like, so the maintenance staff would be, it's really common too for even human building operators. They've been doing this for long time. Even before building automation system and technology, they would know that cold snap is coming. I better shovel some coal in that boiler. I better have this building, coal boiler fired up, hot and ready. So building operators have been paying attention to weather forecasts for a long time. A really good building operator will. So there's nothing new with that. So now we're just using artificial intelligence to kind of do the same thing, but it can. What I have in mind is like reinforcement learning may be able to outperform the building operator. Just think about it as kind of like chess. The reinforcement learning has outperformed the best chess players on the planet. So I think if you can make it into a game, this I know it will outperform the building operator too. So like the idea is that the reinforcement learning or the building operator, they can run the HVAC system 24/7, or they can gamble by turning the equipment off at night to save on some kilowatt hours of electrical energy consumption. But then you run the risk of peaking those electrical bills during weather extreme events. So the idea is that the AI agent will basically learn how to do this through Energy Plus simulations, the physics models. DM me on Discord if some of these concepts are kind of there's so many concepts going on here that are kind of hard to understand, but we're using Energy Plus to simulate the physics of a building. So like this school has there's a calibrated Energy Plus model. AI agents did that relatively easily. That wasn't very hard. And then we're kind of dialing in that model so it meets guideline 14, which is the electrical, the physics model, the physical model meets pretty close to the actual fuel use of the building. And then, so that is what the AI agent gets to play with. So basically, how the AI agent gets real, reinforcement learning agent gets really good at chess is it plays chess tens of thousands of times, trial and error. Pretty common reinforcement learning. People have it play games, whatever. And when it plays the game 10,000, 20,000 times, it figures it out. If the reward policy is good, if it has a good reward policy, um, it should figure out how to run the building optimally. That's what I'm hoping for. Knocking on wood. Um, and then if we really wanted to prototype this, we need a BACnet application. So this is where long story. So sorry it's taking so long. So basically, we we need the AI agent just like a building operator to be able to set the building schedules. So this is Niagara, but I think we're just going to kind of cheat a little bit and then just use BACnet objects that represent a zone on a BACnet server as occupied or unoccupied. So we'll basically just spin up a BACnet app that will just be, there's 6 zones of the school, and it'll just be when the AI agents wants this zone to be occupied, there'll be a BACnet point that'll be zone blah 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 occupied true or false. So that's the way that I'm prototyping this. Is that there would be typical to IoT, there would be a Linux edge device in the building on the operation technology LAN next to the building automation system, typical to all IoT. And then the building automation system would integrate with it, and it would just say zone B, whatever these zones are, a BACnet point representing that zone. And it would be the reinforcement learning agent would just toggle that zone point on or off. So pretty easy. But I think like where I want to start prototyping this is first we need to get a weather forecast data. So we already prototyped that in Backpipes. That is with OpenWeatherMap API. So we've done this. There's some older YouTube videos on this where we've made a BACnet server that just exposes hourly weather forecast data. So let's do it again, but let's instead use the Rusty BACnet stack with Python bindings, because like what I think this app will get into is Python data science application for the reinforcement learning agent. So at least that's where I'm going with it. So, okay, so where should we go with this now? I think I've kind of half-ass explained a little bit about what we're going to try and do here. So let's just see where, another thing worth commenting on too is the next couple of videos I want to talk a little bit about OpenFDD. So this is getting really ready to do some testing with CSV file data. So stay tuned. There's more coming on this SQL and pandas data frame in this rule cookbook. So we'll be talking a little bit about fault detection in the near-term future too on two different applications. One's that does Python and pandas, and another one that does all in Rust. That's Data Fusion SQL. All right, so how should we do this? So the thing is, like, I'm working with I have like two cursor instances running here, and this one is this Linux machine um, that I do OpenFTD development work in, and then the other is this also doing like some of these vibe code apps. So maybe so should we do this? Let's see. So this was vibe code app for where the I think I might just do this outside of um, here. So let's just try. What is this? This might be just a junk folder. So let's just rename this as junk. So let's see. So I'm in Linux. Okay, debating about starting a new agent or not, but it's been a while since I recorded a YouTube video. So let's try doing the OpenWeatherMap tester. Let's copy you again. Here. Okay, so okay, so this is this OpenWeatherMap tester. So remember, we'll need this, the reinforcement learning agent will need to get data once a day from the internet, and OpenWeatherMap API is really nice for this. Let me think. So this is go back to this. I'm just going to CD into the junk folder. Maybe I'll zoom in one more time. Okay, so this is the junk folder here. So it looks like we need a, this is already set up on Madison, Wisconsin, which is good. So we need a .env file. So .env. So this is an environmental variable, and usually this is pretty common. That the it's something that to hide secrets, and I have these all over the place for OpenFTD as well. So like in OpenFTD, this is like how you something that does not get pushed to GitHub, but you put all your passwords in here. Okay, so we need one that says open equals this. Something. Actually, I have to. Stealing my API key, or else I'll just delete it and create a new one. Oh, shoot. So junk. Let's just try this again. Python, WeatherMap APIs, no module found. Yeah, so maybe we need to create. I feel like I haven't been coding in a while. Lots of vibe coding. So let's create a virtual environment. There's this library called .env, I think. So I wonder if we also need requests. Pip install. We have to load our virtual environment. Pip install, that's the Python package manager. Let's just do this .env and then requests, and then let's look at Justin Scott's pip install. So what Justin does is he publishes this package to PyPy, and that's the pretty cool. So that's like the Python package manager is called pip. JavaScript world is called not cargo. Cargo is Rust, and JavaScript is npm, and Python is called pip. Thank you, Justin, for publishing this. And pip install these 3 packages. Again, see what. Oh, it worked. Okay, so that was fast. Cool. So this works. Nice. So in Madison, it's 24 degrees C, 25 degrees C, 50% humidity, and clear sky. It's a very nice weather. I think there was even an arg here that we could do. Degrees Fahrenheit. Anyways, at least like my API key still works. I think like on OpenWeatherMap API, you can still wow. Okay, so they have one call version 4.0, I guess. And I know it's still free, so at least I'm using the free one. Let's see if I can see it. So our request is doing, oh, we're still on 2.5. I thought that that was expired, but at least it's still working, I guess. So looks like they're on version 4.0. I'm surprised version 2.5 still works. So there is a free tier that I'm on. Where is the free tier? Two I'm not paying for it. Free for students. Maybe this is what I meant. All right. Well, it looks like it have version. Actually, we should just ask. Let's just ask AI agent. Just get 24-hour hourly. Pretty sure we can still. At least I was hoping it still can, because I was kind of banking on it for this project. Looks like it's still thinking here. At the time of writing this blog post. So while that finishes, we are in. Let's see, what do we have? Every update that cursor does, it automatically updates the models. So I'm using Grok 4.6, Opus 5, and Opus and Claude Opus 4.8. I still use GPT 5.6 Soul a lot. Like I'm using it quite a bit right here. So I use Codex GPT 5.6 Soul to do a lot of like really big loop engineering for me. So let's check back to this one. Looks like it's found out too that the needed this. So it's actually, it looks like it's actually installing all of the Python modules. That's so weird. Like, um, I've been using AI agents to write tons of code lately, test code. I've been doing tons of software testing, just not a lot of coding. So it's like, even doing like a virtual environment again, it's like I almost forget. Okay, it's like I modified my file somewhere. Cool. Oh, one call. Okay, 3.0. Minute data. This is great. Okay, so like I'm going to tell it mod just for hourly temperature, humidity, and dew point if they have it. Take it, that is all I need. Please. Just the one call. So like what we were talking about, that is it's one of the APIs, weather APIs here. There's 2.0, 3.0, 4.0, and I'm pretty sure that the 2.0 was depreciated already. So debating that stalls. Let's go back to pretty sure Rusty BACnet that there is a model context protocol server. Rusty Haystack will be playing around with that in a little bit too. This may not have been updated for a little while. We'll have to ask Justin if this will be updated here. But this will be kind of handy if the AI agent struggles with creating our code, that it can use the model context server for BACnet. Okay, so let's get back here. Even actually get clone this too. Agent has finished. Just Okay, I just cloned this Rusty BACnet just so the AI agent can look at the code if it needs to. And we have some errors here. Let's suck it back into the junk folder. CD back in the junk. Some kind of error. Okay, so oh no. Okay, so this worked before. It's gonna say this worked before. Separate subscription. All right, so maybe we do need a separate subscription. Coding with AI agents is almost like cheating. All right, so it's saying like the old free account was shut off in June. No leftover hourly. Why did it? So it looks like I have to subscribe to. All right, so it's making me subscribe to Open One Call 3.0. Something doesn't seem right though. Before making an API call, please note that One Call 3.0 is included on one call by call subscription only. Hmm. Well, maybe I'll just have to figure this out. So overly forecast is unavailable. Shoot. This might be a problem. I was hoping to do this all for free. Um, so this is kind of lame. Used to be free. I know that for sure. Don't need historical data. OpenWeatherMap 2.0. Ah, lame. They used to have the one call. Um, for free. Well, lame. Hmm. You can just ask ChatGPT. Open weather map. Have free 20. Usually last one call, pay as you call. All right. Well, maybe I'll just have to figure this out, guys, and then I will probably just catch you on the next video. And then we can dive a little bit deeper into prototyping this once we figure out all of I'll try and figure out these nuances, and then we can also talk a little bit about the reinforcement learning little by little as kind of learn a little bit more about it. But I'm hoping to have the next blog up and running by this weekend. So more to come in the next couple days. Thanks for watching, and I'll talk to you guys later.